I mean, it's going to sound a little corny, but I consider the oil field America's last great bastion of the can-do sweat-of-your-brow success story. And you don't need a pedigree. You don't need an engineering degree. If you know what you're doing and you work hard, I think that this is still the place that people can succeed.
This is EnergyCast, and I'm Jay Downhauer. Today we are talking about my job, water treatment for the fracking industry. As you know, hydraulic fracturing requires water to break up the shale formations containing oil and gas. In the years since the fracking boom began, an entire industry of water management companies operating alongside the oil and gas producers has emerged, and that is a story we are telling today. It's interesting, I once asked someone what they thought the most important energy sector was, and they told me it was water. If you consider that natural gas is now the go-to energy source for a lot of our power and heating needs, that's a good point. In some parts of our country, water is abundant. In other places, like West Texas, where most of the activity is focused, relying on groundwater to pump miles into the earth where it is leaving the water cycle is a difficult proposition. As you will recall, I entered the frack water sector while having a casual conversation one morning on a deer hunting trip. That conversation was the first time I'd ever heard of the concept of recycling frack water that had been used for earlier oil and gas wells. To be working in this sector during the earliest days of water treatment was like being in the wild, wild west, in more ways than one. During our first trade show, one of the first attendees that visited our booth was none other than BP. They were interested. 3 weeks later, we were sitting in a boardroom explaining the concept of recycling frack water to some of the smartest people on the planet and working for a super major. In those days, water recycling was dominated by scrappy little startups. Knowing how industries with fat margins tend to consolidate, I knew it was only a matter of time before these small companies coalesced into bigger and bigger companies. But it sure was crazy while it lasted. Our first job was down in South Texas near a small border town called Cotulla. As the crow flies, we were a few miles from Mexico, and in those days, that was not a safe place to be. We were told, if you see people crossing the work site in black backpacks, get out of there. The first night at the campground where we kept our trailers was a little chilling. It was nonstop stories about cartel gangs, crazy stuff like that. Needless to say, we had worked ourselves up into a frenzy by the end of the night. Then all the guys started pulling out every caliber of firearm there is. You know that scene in Aliens when they disobey orders not to use guns? It was like that.
I'd like to keep this handy for close encounters. I heard that.
So we're all jazzed up. It's the middle of the night. Every time a tree branch brushed the trailers, we think it's go 30. At one point in the middle of the night, one of the guys comes in from the other trailer to use the toilet, and I freaked out, flew out of the bed and dove between the fridge and the oven because they offered the most protection. Covered in cold sweat, I thought, what have I gotten myself into? Turns out, one of the most rewarding experiences of my career. I moved on to other organizations since then and have been able to design some terrific pieces of kit. To be able to work with talented engineers as well as the guys on the ground who know it best and produce a piece of equipment that is designed from both the top down and the ground up has been very rewarding. The oil and gas sector has grown, matured, and evolved over those years. But as our guest today will tell you, that driving spirit still lives on. Our guest today is Clay Moggins, Director of Water Technologies for Select Energy Services, a giant in the water services sector. If it has to do with water in oil and gas, you can bet Select covers it. There's the movement of water from collection areas to the frac pad. That's generally called water transfer. And then there's the water treatment side, which is where Clay resides. I met Clay in 2011 after one of the companies I was working for had been partially acquired by Select. We've been friends since then, and I don't think you'll find a more knowledgeable person in the sector. Clay is an A&M grad with a PhD in chemical engineering. Prior to that, he worked for Siemens before hearing the call to come to the oil patch. He wanted you to know that he is not speaking on behalf of the company as a spokesman, but I seriously doubt you could find a representative for Select or the industry than this guy. I hope you enjoy my conversation with Clay Moggins. We're here with Clay Boggins, Select Energy Services. And Clay, tell everybody your title and really what you do for Select.
Sure thing, you bet. My own bio intro is I'm a PhD chemical engineer. I graduated from A&M about 6 years ago. I totally bought into the Aubrey McClendon message about making America great through the frack revolution. And I still do. And what an exciting world it's been. So what I do right now is I work for the largest water-focused company in the U.S. oil field. And I'm our Director of Water Technologies. And mostly my role is strategic and technical. My job is really to look at, what is the best practice today, what's going to be the best practice in 6 months, and what's going to be the best practices beyond, and then try to steer my corporate leadership in the right direction to kind of keep us in top and in tune with that. It's been a fun job. One day I'll talk about reaction rate kinetics and mass transfer limitations, wearing a coat and tie at a conference, and then the next day I'll be answering questions on how do we address a problem with a pit in North Dakota that's been overrun by newts. It's just every day is an exciting new day.
I want everyone to understand that Select does the gamut, but what I'm really wanting to focus on is your job, is the water treatment component. And so what I'd like to talk about, first of all, is frack water recycling. That's an important deal. Because we're business focused here on this podcast, explain for the initiated how the economics work when it comes to frack water recycling.
Yeah, you bet. To really answer that, let me take a minute to explain the whole water story. When it comes to fracking, the first thing you have to do is get the water that you're going to frack with. There's no standardized price on any of this stuff. The cost of the water is going to be anywhere between 10 cents to $1 for a barrel of water, which is 42 gallons. Once it's purchased, you still have to get it to the frack. And moving it there can easily be another $1 a barrel. And we're talking a lot of water. We're talking, 250,000 barrel fracks is very common. So then once you've used that water to execute the frack, it starts coming back with the oil. Now the well's going to be producing, you're going to be doing flow back and then production. And so what do you do with that? And so you have to move that somewhere to get rid of it. So there's the cost of movement of that now distressed water. That water is going to be 3 times saltier than seawater, depending. It's going to have some oils in it. It's going to have other contaminants in it. It may even have some biocontaminant in it from downhole. Moving that water, then you're going to go to what we all call a disposal well. It's going to go downhole, usually at a price point of, we'll say nominally 50 cents a barrel. So if you add all those numbers up, your total water cycle on that can easily be up to $4 a barrel. So then the question comes, what about recycle then? There are multiple reasons that people recycle, multiple advantages. The first would be, of course, the economic. And in the end, that's what drives everything, right? And the economics are great because you're eliminating the source and disposal, but depending on how clever the program's set up, you can also take a big chunk out of the movement costs, which are very high.
When it comes to recycling, there's no silver bullet. Explain some of the technologies that are common with recycling.
Most of them will leave the salt in the water. What we're focusing on usually is getting rid of things like turbidity, which is just how cloudy the water is, floating things, dissolved iron. So how do you do that? And there's a bunch of ways to do it. And they're all credible and viable. There's just different reasons you'll pick different ones. But, one of the common ones is pH adjustment-based precipitation using things like inclined plates or just settling tanks. In shorthand, we just call it flock and drop. Another variation of this is oxidation-based chemistry, where you oxidize the dissolved iron into an insoluble form. Another common technology or approach is bubble flotation. A lot of times you'll add an oxidizer or something to manage the iron, and then you use bubbles, which will float out oils and suspended particulates. And then you can combine that with post-filtration to do an even better job. Other technologies are things like electrocoagulation, which is some of the chemistry you're adding via the electrodes being electrolyzed into the water. There are also some interesting heavy aeration solutions that are infrastructure projects that large operators will sometimes do, where they'll basically take their produced water and essentially do the same thing as a municipal biological treatment plant. And then you can even do things like tend bugs in there, where you grow benign microorganisms in there, which essentially deplete the water of nutrients and whatnot. Those are the ones that I'm seeing most common on what I call the clean brine recycle types of technologies.
One of the things that a lot of people may be thinking is how is this different from municipal water treatment?
We have very different goals. First off, municipal water is taking fresh water that's contaminated with organic materials and removing those organic materials. Most of the time, we're taking saline water that's contaminated with some organic materials, but also contaminated with certain inorganic materials, such as iron and so forth. And we're removing those items. And for the most part, if some oil slips through, it's not that big a deal. We're not as focused on the compatibility with a wildlife environment of our discharge, because that's not where the water's going.
And the other thing, of course, would be the water that's coming into a municipal facility may be a whole lot less variable than some of the water you see when you're recycling frack water. Am I right?
Yeah, that's a very good point. Yeah, because at a municipal plant, they're going to have a fairly standard volumetric flow rate on schedule every day of a fairly standard composition. Whereas you're right, our water may be running full capacity for 3 or 4 weeks, and then boom, it's shut down, and then start up again in a few weeks or months. And so systems that can handle that, biological systems struggle with that. Most of our solutions tend to be mechanical based and chemical based.
When it comes to the client, and we're talking about an operator, the company actually producing the hydrocarbons for simplicity's sake. So you're talking to these clients, these operators. The definition of what is considered clean water depends from client to client, does it not?
Yeah, and that can be all over the map. It's funneled to a more common spec, but by no means is there a standard spec across the industry still. And occasionally I'll get a spec that'll be remarkably tight on some things and other specs that are quite loose. Generally, as a water recycler, the baseline of what we try to do is we pay attention to 3 things: the iron, the turbidity, and the bacteria. If we can take a dark, cloudy water that has a high bacteria load and a whole lot of dissolved iron in it and produce a relatively clear water, I call it lake water spec. For most people, that's fine. Most of what we've been talking about is what I call treat and batch side, where we take produced water and flow back water and we treat it up and we'll store it in tanks and ponds and pits. And then they'll draw from that all at once when they need to do the frack. So we'll run for a month or so, build up the inventory, then boom, they'll frack with it. There's also what you call frack on the fly. On the other side, when they're doing the frack, they're also doing a treatment to that water. And usually when they do that, that'll be things like the disinfection.
This is interesting, this dynamic with the operators, the clients. In some of the early days, I was surprised how much we were explaining to the operators. These are big companies, downtown towers with the names on the front. I always tell people this. It was kind of like the pharmaceutical rep explaining drugs to the doctors. You're talking to engineers and geologists and guys like that. How has that dynamic changed as the operators have gotten more sophisticated over the years? Are you explaining as much to them these days? How much do they know in the room?
So that has definitely changed. It used to be kind of like you're trying to explain rocket engine design theory to a pilot while he's engaging in a difficult takeoff that he doesn't have enough time to do. He didn't care. He had more wells to frack than he could shake a stick at. On top of that, it was new. It was just this additional variable. It was just perceived as risk enhancement, problem enhancement with his well. And in fairness, some of the early operations did have some bumps with people. What's happened is recycling has become a lot more commonplace. There's a lot of corporate directives that have been backed up by action to do it on recycling. The customer wants to talk about it. The engineers, the operators want to talk about the science, the chemistry, what's going on. And of course, I live for that. That's fun stuff.
Let's talk briefly about some of the other water treatments out there. In addition to the recycling component, many in the industry are using biocides to kill bacteria and other microbes. Explain why that's important to kill bacteria that's going down back into the earth.
This is really important. When you use fresh water, that water will have a fairly low carbon content. It's going to have a fairly low bacteria biological loading to begin with. If you take produced water, that is a high carbon load, salty water laden with nutrients of the exact composition that what's going to be downhole. Eventually, life will take hold, and then it's going to thrive. And these would be the bugs that basically do things like they're anaerobic bacteria that'll do things like use sulfate for respiration, thus generating H2S gases. So disinfection is huge. The old approach of adding various liquid biocides that we've been using for many decades in the industry, you can still do that, and a lot of people do, and it still sometimes works. What the industry's really done and made a big shift is to oxidizing biocides. And the reason for that is these things are great. They're fast and they're complete, or at least very nearly complete. So in a matter of minutes, you can fully disinfect water. What we'll do is we'll add some oxidizing biocide to that water while it's transferring. Then what we'll do is we'll either measure real time with response sensors, or a guy will check manually, and that'll tell us if we have any residual oxidizer that we added. And if we have residual oxidizer after so many minutes of reaction time, then we know we've for all practical purposes, fully disinfected that water.
Let's talk about the third way as well. Are there any other services in water treatment that you've seen? I once developed some technology to treat sulfate. It was basically an industrial water softener, but there are a lot of other little things that sometimes the client wants you to take out of the water, and sometimes those treatments are a little bit specialized. What have you worked on in the past?
So yeah, that's a fun topic. In my opinion, the real heroes of recycling are actually the frack engineers. It's not us recyclers, because they have figured out how to frack with more and more difficult water. And that's allowed us to treat and recycle water with less and less rigor to the various things that you're talking about. On the sulfate example, we have a minor role in a project right now, actually, on removing sulfate from water for frack use. So for the most part, we generally focus on the big three that I mentioned: your turbidity, your iron, your bacteria. Other specialty things, big ones that people would love to remove, are things like boron, although less so these days. And then hardness. They're more of a challenge for your frack chemists. They have more interferences with your frack chemistry. So if we can remove those, we will.
You mentioned the salt issue, and I think a lot of people are wondering, well, why wouldn't you have to desalinate? And I've been pitched desalination options in the past, but that's not necessary.
As an engineer, it's kind of a heartbreaker because I find the desalination technology some of the coolest technical solutions to work on, but the reality is the economics just aren't necessary anymore. They have figured out how to frack with high saline water very easily now, and so for the most part, it's just not a common topic. It's been argued with some credibility that fracking with salt water will produce a better well than fracking with fresh water, and produced water is, if nothing else, salty. Fresh water causes certain clays and materials to expand and swell, and salt water causes them to expand and swell less, which helps with your pore clearance downhole. And then the other aspect has to do with just your water compatibility with the material that's already downhole. So you've got a water that you're fracking with that's already in salinity equilibrium with the entire system downhole. So it's not dissolving off salts and breaking off chunks of Lord knows what while it's downhole doing strange things. That water's already compatible and saturated with everything that's downhole.
Here's another question. I'm just thinking of it while we're talking, is being able to kind of your KPI. Key performance indicators, right? Has there been any good studies, Clay, about how effective certain water treatments work on the geology versus others? In other words, do you get more production if you take a lot of dissolved iron out versus if you, say, frack with dirtier water?
Yeah, I have seen some studies published. Halliburton did a nice paper on that. And what they found was that a high turbidity water would basically plug up the proppant. So why is one good and the other one not good, and how does that interact? I think we're all still trying to figure that out.
I was interested because one time up north, they wanted us to treat sulfates like I'd done down near San Angelo. And then they were like, we want to treat sulfates. All right, now show us how treating for sulfates will yield better production. I was like, you're the one who wants the treatment. Now I've got to go prove the treatment that you want? That seemed a little funny to me. Anyway, let's get more into a macro look at all of this. Explain how many oil field services companies came into the market at the beginning of the fracking boom and what it looks like now.
Man, I don't know. There's probably, jeepers, I would say somewhere 50 to 100 that have tried to get into the water management, water recycle game that just didn't make it. You know, it's a tough business. A lot of people, I think, were kind of misled by the pundits. There was this general feeling that all of the operators are going to have to recycle water no matter what, and they're going to pay whatever you want because they're printing money with a printing press. It doesn't play out like that. You had that on one end motivating a lot of people to get into it, combined with, we were all learning. A lot of people came in with solutions from municipal or desalination technologies, from seawater desalination technologies, which are completely different systems and worlds, and tried to apply them to this, and it just cratered within a matter of hours, if that. The various oils and whatnots and contaminants that are in our waters would just wreck that whole system. Combine that with, it's been a fast pace to obsolescence. 5 years ago, you could recycle water realistically in cell jobs, and people were doing it for $1.50 plus a barrel. Today, that's a total non-starter. The company I work for, we took a different take on that. Rather than spending millions of dollars of developing our own solution suite, we actually went with a partner approach to whoever the best-in-class providers were amongst the spectrum of solutions. And that had pluses and minuses, but one of the things is it did help protect us from basically the inevitable obsolescence of your fleet that a lot of people went through.
It would seem to me, Clay, I kind of see the whole fracking industry as in two phases. Now what we're seeing is what I like to consider shale 2.0. right? And now the prices have kind of recovered a little bit. Everything post-bust is just a whole new economic paradigm. People are really tightened up in the shale 1.0. There might have been a little bit too much largesse, and you just can't sustain these days with that old mindset.
Absolutely. Oh, absolutely. One of the things that's happened is the activities return, but the value of the product and the openness of operator budgets has not. You still have to definitely sharpen your pencil to be in this game. And what's interesting, though, is during the bust of 2014, recycling actually did really well. I think that one of the reasons that happened is because operators had a lot of smart people who had more time on their hands to evaluate things, and this actually saves money. There's been some real success stories during that downturn that, in a way, I don't know if would have happened if it wasn't that downturn.
One of the things I always notice when I first got into this is, look, there was a lot of small startup companies, and some of them just didn't make it. I guess it's just the MBA in me looking at it when I was originally getting involved in this was eventually there's going to be consolidation. And that's what we've seen is you got the companies like Select out there and some other large companies. Is there room for the scrappy little startups in this space?
I would say absolutely. I mean, it's going to sound a little corny, but I consider the oil field America's last great bastion of the can-do sweat of your brow success story. And you don't need a pedigree. You don't need an engineering degree. You can just, if you know what you're doing and you work hard, I think that this is still the place that people can succeed. And that's one of the beauties I see in the industry. One of the challenges that a new entry will have is most of the easy stuff has been done. The clever ideas that you can do in your garage, a lot of people have kind of thought about that now. There's still room. I'm still waiting to talk to anybody who's got a great idea, but I still think there's room for the scrappy upstart, and I can't wait to see the next one.
And we certainly look forward to seeing who else comes along. Okay, so Clay, I am going to finish up with something I do for all my guests, which is I ask them about what they think about all the other energy technologies out there. And I just want you to tell me first thought that comes to your head when I mention all these, okay?
That sounds fun. Sure.
Okay, first one is natural gas.
I love natural gas. I wish that our motor vehicle fuel vision that Aubrey McClendon had with natural gas took off. And I know there's trade-offs to it, but there's so many things I love about natural gas. So, big fan of natural gas.
Crude oil.
One of the best gifts to mankind. The energy density of crude oil, it's massive amounts of free energy just sitting below the ground.
Nuclear.
I like nuclear. I'm a big fan of nuclear. Do we have the right balance of regulation, safety engineering to allow cost effectiveness? I guess I'll let other people figure that out. But I think nuclear is a cool power.
Coal.
I don't know. I'm not a big fan of coal, to be honest. I mean, it's all right. It's a good staple energy, but I'll just leave it at that.
Wind.
I think wind has its place. It's a neat technology. I tell you what, though, if I lived on a beautiful ranch house with 1 million acres behind that ranch and I had the choice to put wind power out there in that field or frack the hell out of that field, I would frack that field because 10 years from now, it'll be a beautiful field.
I'm sorry. Solar.
Cool tech, has its place. I think it's a little oversold.
Biofuels.
I would say that was a wasted shot. I am not a believer in biofuels at all. I think they're a boondoggle.
Fuel cells.
In 10 years, we'll all be having fuel cells. That's the line I've heard all my life. So I guess in 10 years, we're all going to be driving with fuel cells.
Check out episode 2 that I've done. Hydroelectric.
Love it. Obviously, you're limited to where you can apply it. And there's some controversy. I don't want to wreck a beautiful natural park or something with it, but big fan.
Geothermal.
I don't know a lot about it. It's a cool tech, but I think it's kind of expensive, isn't it? I mean, it's pretty involved. You got to drill down pretty deep, right?
I actually spoke to a geothermal guy in DC. Their trade association sucks, which may be part of the reason why we haven't heard very much from electric vehicles.
So I used to think this was the Paul Blart Mall Cop type vehicle until I drove a Tesla. And dude, the thing was great. We'll see what the future brings on those. I think they've got to figure out the battery technology still. And I look forward to them figuring that out.
And finally, nuclear fusion.
I got to tell you, Jay, I have lost my faith that the physics is going to work on a practical level. A lot of smart people have been working on that really hard for a long time, and they've got, frankly, nothing. What physics are we going to discover? What engineering are we going to discover that's going to change that? If we haven't discovered it by now. So I'm kind of bummed out about that.
All right, Clay Moggins, thank you so much for your time.
You bet, Jay. It was a pleasure.
That was Clay Moggins, Director of Water Technologies for Select Energy Services. We spoke last spring just after Select had gone public. I felt honored to be granted one of the first interviews after the offering had been made. Select is headquarters in Gainesville, Texas, and Clay works in downtown Fort Worth. I want to thank Clay for helping to make this interview happen. Also, many thanks to Taylor Torsellini in the marketing department for all the great images. You can find those on Instagram at Host Energy and online at energy-cast.com. Music was produced by Sean Stroop at Stroop Loops. All guests are sent the raw and completed versions of the show to ensure they've been treated fairly. So far, no complaints. That wraps up episode 19. Next week, we finally unravel the mysteries of nuclear fusion with one of the nation's authorities on this technology of the future. Until then, I'm Jay Dowenhauer. We'll see you next time.